ThoR is a collaborative EU-Japan project which is funded equally by the European Commission under its Horizon 2020 framework and via NACT on the Japanese side. ThoR deals with terahertz links for backhaul fronthaul application, and one of the main goals of ThoR is to demonstrate a 300 GHz wireless backhaul fronthaul link with the transmission of real data. The consortium consists of 12 partners, 5 of them from Japan and 7 of them from the European Commission, namely France, Israel, the United Kingdom and Germany. And the partners are from research institutes, from industry and also from university. The project is coordinated on the Japanese side from Waseda University and on the European side from TU Braunschweig.
For beyond 5G or 6G mobile systems, we need a lot of base stations to provide high-performance wireless services. The number of base stations will be larger than that of users. The base station should be connected to the internet via mobile backhaul and fronthaul links, where the required transmission capacity will be larger than more than 100 gigabits per second in beyond 5G systems. Optical fibers are commonly used for high-speed transmission. However, it would be rather difficult to make all base stations connected only by optical fibers, because we need a huge number of links. So, we have to use seamless access networks consisting of wired and wireless links, where the transmission capacity gap between wired and wireless links should be small. As you know, terahertz can offer high-speed transmission. The ThoR project focuses on device and system technologies towards over 100 gigabit per second terahertz transmission.
The ThoR project is also highly linked to standardization and regulation issues. For example, the ThoR demonstrator implements the newly generated standard IEEE 82.15.3d in one of his demonstration version. And in the area of spectrum regulation, ThoR has provided input to the preparation of the World Radio Conference 2019 and is now working towards input to the World Radio Conference 2023.
So while terahertz communication was sort of an uncharted science for many years, recently the first frequency standard has been introduced by the IEEE. With the ThoR project, we are addressing exactly this new frequency standard, and our system approach is compliant to this new standard. We are using channel aggregation of many individual already wideband channels supporting data rates of up to 10 gigabit per second per channel, and we are aggregating several of these channels and upconvert them into the terahertz frequency range where they are being transmitted in a point-to-point link over the air, for instance from base station to base station, and then down converted again and separated again into the individual channels and then handled by the digital signal processing.
The frequency bands from 0 up to 300 gigahertz are full of different applications, for example 3G, 4G, LTE, or next year also 5G mobile applications. For Deutsche Telekom, higher speed applications includes the last mile to the customer, high speed, then augmented reality, virtual reality for mobile users, as well as Internet of Things, and I believe further high-speed applications for future networks.
So as you may know, in terahertz communication there is many development right now due to the impact of potential future needs. And there is basically two approaches. There is an electronic approach with solid-state devices and photonic approach. Both of them have some bottlenecks or advantages. For example, electronic systems are more powerful usually but reduced in terms of bandwidth, and photonic systems are more wideband and the signal integrity is better, but the problem is usually the power. So in order to tackle these problems, in ThoR we are going to combine both photonic systems and electronic systems to take advantage of both advantages. So one of the key points of the ThoR project is this association between two kinds of systems, which is very innovative because this photonic approach and electronic approach is very different in terms of a concept.
So in ThoR, not only are we combining photonic and electronic technologies in the terahertz transmitters and receivers, but also for the first time we are attempting to integrate such a broadband terahertz link seamlessly into the internet infrastructure. That way allowing us to transmit real user data with extremely high bandwidth across a terahertz link.
Okay, so the unique aspect of this ThoR project is cross and strong collaboration between EU and Japan partners. And for example, terahertz amplifier is very important to achieve our goal. And NEC from Japan, they have very strong technologies to develop this kind of terahertz amplifier. So this is the one point that Japan has the good technology in terahertz band.
In ThoR project, we will perform high-speed transmission demonstration to show the capability of the terahertz systems, which can be used for high-speed mobile backhaul or front haul. The terahertz technologies can be also used for future wireless LAN and data center applications. The expected outcome of this project will be indispensable items in our daily life.